everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss problem solving on DC generator. So here first problem. A 4-pole lap wound DC shunt generator delivers 200 amps at terminal voltage of 250 volts. It has a field resistance and armature resistance of 50 ohms and 0.05 ohms respectively. Neglecting brush drop and determine armature current and current per parallel path and EMF generated and power delivered. So solution for this. So first draw the lap DC shunt generator. First it delivers 200 amps current. That means this is IL. So let me change the color over here. So first here this is IL. This is IL. So number of poles are P and terminal voltage V equals to 250 volts. And this is the field winding resistance RSH, and this is the armature winding resistance RA. Now from this calculate the IA armature current and number of parallel paths current, number of parallel paths A, and induced EMF EG and power delivered here and PG. So first here armature current. How you will calculate the armature current? So first here armature current. So first draw the circuit. How you will draw the circuit? This is the shunt. This is armature winding resistance. Here it is delivering the current IL. This is the load we are connecting. And this load voltage is terminal voltage is 250 and this is 200 amperes IL. And next this is RA 0.05 ohms. This is RA. And next RSH is 50 ohms. So now here to calculate the armature current here, to calculate the armature current IA here. So IA equals to this IA equals to IL plus ISH. This IA equals to IL plus ISH. So first calculate the IL is okay here. ISH value. ISH can be calculated from here. V by RSH. So V by this terminal voltage V by this RSH. So same voltage developed across each element in case of parallel circuit. So same shunt field winding voltage and this armature voltage and this terminal voltage is same V by RSH. So here V is 250 volts and RSH is 50 ohms. So that equals to 5 amperes. Now here this ISH is 5 ampere. This IL is 200 amperes. So now this current is total IA equals to 205 amperes. So first question is over. So now current per parallel path. So here, so that current per parallel paths here, number of parallel paths here. This is current for path. Number of parallel paths. This is lap wound DC generator, DC shunt generator for lap connection. A lap connection A equals to P. So number of parallel paths equals to here 4. So this 4 number of parallel paths are 4. So now current per parallel paths means this armature current divided by this P. A equals to P. In case of wave connected, that value A equals to 2. Wave connected. Now here this one is 205 divided by 4, that equals to 51.25 amperes. So now here next question, EMF generator. EMF generator here is if you apply KVL in this loop. So this is induced EMF EG equals to this voltage terminal voltage plus here IARE. IARE. This terminal voltage IARE. So now here V is 250 volts and IA is 205 into RA value is 0.05. So now the value is 260.25. So now next, power delivered. Power delivered equals to PG equals to EG into IA. So now here 260.25 into 205. So that value equals to 53.35 kilowatts. Now next problem. Second problem, a 30 kilowatts 300 volts DC shunt generator having armature resistance and field winding resistance 0.05 ohms and field winding resistance, shunt resistance is 100 ohms respectively. Calculate the power delivered by the armature when it delivers output power. So first same diagram here. This is the diagram. This is armature winding and this is the field winding. This is the load shunt generator. So now here RA and here RSH and this is the terminal voltage V. This is IL and this one is the ISH and this is the IA. And next, this is terminal voltage V. This is induced EMF EG. So here power delivered PG you need to calculate. So same procedure. So already we discussed first problem. So same procedure here. So terminal voltage is 300 volts. This one, and here line voltage, load voltage is load current is not given. So load current is calculated from the 330 kilowatts. So 30 kilowatts by 300 means that is current. So I equals to power divided by voltage here. So from this you can calculate the line load current. So now here. So now this one. So 30 kilowatts, 30 into 10 power 3 and 300 volts divided by that equals to 100 amperes. So now ISH equals to ISH. So this is okay. Armature current. How you will calculate the armature current? Armature current equals to IL plus ISH plus this IA. If you apply KCL at this node, IA equals to IL plus ISH. Sum of entering currents equals to sum of leaving currents. Now here IL is calculated here, this one, and ISH same thing here, this voltage divided by this resistance. This resistance is 100 ohms. So that equals to 300 volts divided by 100 ohms. RSH is here 100 and this terminal voltage is here voltage 300 volts. Now here 100, this is 100 ampere IL and shunt current is 3 ampere. So now armature current is 103 amperes. So now here to calculate this power delivered, so PG equals to EG into IA. IA we calculated. So from the ISH and IL, ISH can be calculated from the V and RSH and IL is calculated from the power and voltage. So IL, ISH and IA we calculated. Now here EG. How we will calculate the EG, generated power? So same thing here. If you apply KVL here in this loop, EG equals to V plus IARE. IARE. So now V equals to 300 volts in plus 103 amperes into 0.05. This is RA, armature winding resistance. This is armature winding resistance RA. Now this value EG equals to 305.15 volts. So this one. Now here power delivered equals to Eg into Ia, that equals to 305.15 into 103. So that equals to 31.43 kilowatts. Now third problem. A 4-pole DC generator with wave-wound armature have 51 slots and having 24 conductors. Rotate to give induced EMF Eg equals to 220 volts. So what will be the voltage developed if the winding is lap and armature rotates at the same speed? So first given data. So given data, number of poles equals to P, and this is wave connected. A equals to 2, and number of Z equals to 51 into 24. Total number of conductors equals to number of slots into per slot number of conductors. So this one 51 into 24, and induced EMF Eg equals to, this is Eg equals to 220 volts. So from this, if it is lap wound, so calculate. So same for the same speed. So calculate the induced EMF if it is lap connected. So first calculate the speed for the same speed. So first here Eg equals to, we know this, 220 volts, and next Eg equals Zn5 by 60 into P by A. We know very well this formula. So phi equals to, phi is not given, phi is constant here. So phi is 0.01 is given, and next Z is 51 into 24, and next N you need to calculate, and 60. P, number of poles are P and A equals to, this is P and A equals to 2. This is A. So here assume the flux per pole is 0.01. And next case, calculate the speed. And Eg equals to 5Zn by 60 into P by A. Phi value is fixed and N value is fixed and Z value is fixed. And number of poles are fixed, and A equals to P for lap winding. This is for lap winding. Otherwise, you can calculate equals Eg equals Zn5 by 60 into P by A. So Eg is indirectly proportional to the 1 by A. So now here Eg1 divided by Eg2 equals to A2 divided by A1. A2 is for A equals to P. A equals to P, this one, that equals to 2 divided by, so here lap winding 4 and 2. Here Eg1, Eg2 equals to, so this value is 110. So 4 and 2. So divided by 2, this is Eg2, 220 by 2, that equals to Eg2. So that equals to 110 volts. So now here, next problem, a DC shunt generator delivers IL value 496 amperes at 440 volts to the load. So this is V and this one is the IL. The resistance of shunt field coil is 100 ohms and that armature winding is 0.202 ohms. So calculate the induced EMF in the coil of armature. Same here Eg formula. So Eg equals to so not this formula, Zn5 by 60 into P by A. Another formula, V plus Ia into Ra. Same here, we know this two V value and Ra value, but here Ia equals to IL plus ISH. and this IL is calculated from the V by RSH. Sorry, IL is same as it is. This one is V by RSH. So now see the same formula here. This is plus. This one is plus. This one is plus. EG equals to V plus IARA, and 440 volts plus 496 into this is IL 0.02, and this one is 440 plus 9.92. This value is 449.92 volts. After that, load current at which maximum efficiency. This is okay. A 4-pole 230 volts series wave connected armature with 1254 conductors with flux per pole 22 milliwebers and takes 50 amperes for motoring. So the armature and series field coil resistance. This is armature RA and this one is the R series. And calculate the speed and torque developed in watts. So now here series this is the RA and this one is the R series, I series and IA and this is IL. So now here, so first here for lap connection, EMF generated in the armature winding that equals EG equals to V plus IARA. So this is the load. This is V. So V plus IARA plus I series R series, but IA equals to I series. This one. So same thing here, V plus IA common RA plus R series, that equals to 230. This one 230 V and 50 0.3 plus 0.2, that equals to 255 volts. Now EG equals to 5NZ divided by 60 into P by A. So now here lap connected or wave connected, it is a wave connected, A equals to 2. Now here flux is 22 milliwebers, this one, and Z is 1254, and N you need to calculate here speed, and 60 is as it is number of poles are P. So that value equals to 277 RPM. So speed is we calculated N. And next, a shunt generator has 4-pole lap wound armature having 24 slots and 10 conductor per slot. So flux per pole is 0.04 webers and the speed is 1500 RPM. So calculate the EMF generated in the armature. So what would be the generated EMF if the wave winding is wave connected? It is a lap wound connection. The armature is generated. So this is the formula. We know very well this formula. So EG equals to Zn5 by 60 into P by A. So now here, so flux value and this total number of conductors Z equals to 24 into 10. So 24 slots and in conductors per slot is 10. Next, speed is 1500 rpm, z n equals to, this is n, and number of poles p here, and next it is the lap connected a equals to 2, it is lap connected a equals to 2. So now here induced EMF is Eg equals to 240 volts. So now here what would be generated EMF if it is wave connected? Same thing here. So if it is wave connected, here same thing, flux per pole phi z, and this one is n, and this is number of poles here 60 into 2, a equals to 2, this one, and this value is 480 volts. Next, a 4-pole DC shunt generator with lap connected armature has field armature resistance R 50 ohms and 0.1 respectively. If the generator supplies 100 volts and 40 watts lamps, calculate the armature current and current in each armature conductor and the generated EMF. So take 1 volt. So here brush drop is 1 volt. So now here power delivered is here 60 watts, 60 into 40. So how you will calculate this? So total number of bulbs here, lamps here 60, and this one. So 60 is a number and 40 watts lamps. So total power delivered here, so 60 into 40, so that is 2400 watts. And next, ISH. ISH can be calculated. So first here EG equals to V plus IARE. So now here IA equals to IL plus ISH, and IL can be calculated from here and ISH can calculated from here. So now here ISH equals to this V by RSH. V is 100 volts and RSH is 50 ohms, this one. So this value is 2 amperes, this one, and IL equals to total power 2400, this one, divided by 100 volts. So P by V. So that equals to 24 amperes. So now this 24 amperes plus 2 amperes is the armature current. So from this you can calculate the, so now here armature conductor, so current in each conductor means this armature current divided by number of parallel paths. Here number of parallel paths, if it is a lap connected means A equals to 4, and 26 by 4, that equals to 6.5 amperes. So now EG equals to V plus IARA plus brush voltage drop. Brush voltage drop is 1 volt. 1 volt means here we have 2 brushes, 2 into 1 means that is 2. And next here this is armature resistance 0.1, and 26 is this one, and 100 volts. This is 104.6 volts is the generated EMF. Next, a 4-pole armature of DC generator has 654 lap connected conductors and it is driven at 1200 rpm. Calculate the useful flux per pole required to generate an EMF of 250 volts. So now here solution for this, EG equals to Zn 5 by 60 into P by A. So now here flux, so useful flux can be calculated. So direct formula here. So now here if you separate it, so LHS side, so phi equals to E into 60 into P by Z n phi. Here this is N, this is P, and if it is a lap connected, A equals to P equals to 4, and this is Z. So substitute in this, you will get the useful flux is 0.02 Webers. Next, a DC shunt generator running at 1500 RPM delivers 50 kilowatts at 200 volts. The armature and field resistance are 0.02 and 40 ohms respectively. Calculate the generated EMF if brush drop of 1 volt and now same thing here. So now here EG equals to V plus IARE. So now this IA is this one and RA is we know very well. This one is RA and V is this one. So now here this IL plus ISH, IA equals to IL plus ISH means ISH equals to V by RSH and IL equals to P by V. So substituting this, V is 200 volts divided by this 40 ohms, that is 5 amperes. And next this is P by V. So P is 50 kilowatt, 50 into 10 power 3 divided by 200 volts, that is 250 amperes. So now 250 amperes plus 5 is 255 amperes. Next, induced EMF EG equals to this formula plus voltage drop, brush voltage drop. So now here this brush voltage drop is 1 into 2 brushes means 2 into 1, that is 2 volts. And same thing, this is here and RA is this one and this is 200 volts. So this value is 207.1 volt. An 8-pole lap connected armature has 960 conductors, a flux of 40 milliwebers per pole and speed is 400 RPM. So calculate the EMF generated. If the armature were wave connected at what speed must it be driven to generate 400 volts? So now here EG equals to Zn5 by 60. So same thing here. So here we solve this problem also. EG equals to Zn5 by 60 into P by A. So 40 milliwebers. Here 40 milliwebers is this one 5 and 960 is Z. And next 400 is speed 400 and A equals number of poles and number of parallel paths is here. A equals to P equals to 8. It is lap connected, this one. So now here if you substitute in this 250 volts, so now it is a wave connected, calculate the speed. Same speed here 250 volts, 256 this one, this is 256 and calculate the speed when it is a wave connected means 60 into 2, not 8 here. So now here N equals to 120 into EG divided by 5ZP. So now if you substitute in this, you will get the speed equals to 100 RPM. Next problem. An 8-pole lap connected armature has 40 slots with armature conductors per slot is 12 and generate an voltage of 500 volts. Determine the speed at which it is running if flux per pole is 50 milliwebers. So here same thing here, speed. So EG equals to Zn5 by 60 into P by A and N equals to same thing here 60 into A into EG divided by 5ZP. So substitute here, this is 60 and A equals to 8 for A equals to P, that equals to 8. Number of poles here 8 and 500 is 500. What about 500 is Eg, and this is the flux, and this is number of conductors. So 50 into here this 40 into 20 Z equals to 40 number of slots and 12 conductors per slot, and 8 is the A. 250 250 na 2 250 1250 rpm. An 8 pole DC generator has 500 armature conductors and useful flux per pole of 0.065 Webers. What will be the EMF generated if it is lab connected and runs at 1000 rpm? And at what speed it must be driven to produce the same EMF if it is wave connected? So now here solution for this. If it is a lab connected, what will be the EMF first? So EMF means here A equals to number of poles, and it is a lab connected. So A equals to P equals to 8. Same thing here. This is P and this is A, and speed is N is this one, and Z equals to 500. Z, this is Z, and here what about Z? Here Z, and this is a flux, and 60. So induced EMF if it is lab connected, here Eg equals to 541.67 volts. So same EMF. So for the same EMF, it is a wave connected. So at what speed it must be driven? So now here, so a wave connected Eg equals 5Z 5 by 120. So now here 120 into Eg by 5ZP. So now here. So now here it is a wave connected means A equals to 2. Just substitute A equals to 2 and Eg equals to 541.67, this one. So that speed equals to 250 rpm. Next, a 4-pole 500 rpm DC generator has lap wound armature having 24 slots with 10 conductors per slot. If the flux per pole is 0.04 Webers, so calculate the EMF generated in the armature, and what would be the generated EMF if it is winding is wave connected. So same thing here. Eg equals to Zn 5 by 60 into P by A. So flux this one 5, and next number of conductors 24 into 10 Z, this one, and 1500 rpm this one N, and number of poles P and number of poles A equals to P equals to for lap winding A equals to 4. And if it is wave connected, same, this is 240 here, 480 volts here. I hope all these problems are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.